Let's go through LeetCode 498 diagonal traversal given an n multiple by n matrix mat. Return an array of all the elements of the array in a diagonal order. So about the diagonal order, in this example, it gives us the directions. So let's look at the example. At the beginning, we are sit at the left top, that is the cell 00, this kind of cell, and it is trying to go into upright, and when it hit to top, it will go one step to the right. And I say after this, it changes to another state, which will go to left bottom. So after it hit to the first column, it will go down for one step. Then I'm going to switch it to another state that is going up state. So for the going up state, if it hit to the right edge, it will just go one step to the bottom. And then after that, the switch to the down state. I would say it's going to the left bottom, and when it hit the bottom, it is going to the right for one step. And after that, still it hit going up, top up. So I would like to divide this kind of question into two kind of state. One is a red state, one is a blue state. So let's call the red state that is up. At the beginning, I say up is true because it's at the cell 00. And let's get if A equals net length. And M equals net 0 dot length. I'm going to create a result array. Just mirror it and okay. I'm also going to use a row variable as row equals to 0, column equals 0, which will represent the positions of cell in the mat. And also I'm going to have an index variable, which will represent the result index. So we'll iterate the row and column while row multiplied by and last column. If it's smaller than and multiplied by m, that means it's we haven't go to the right bottom. So as a result, index equals mat row. So let's look at the conditions. If this is in the up state, and also it hit to the right edge, if it's up and hit the right edge, it's calling equals m minus 1. Then for the red line will go down for one step, so that is row plus plus. And if we go down for one step, it will switch to the blue line. So I say up equals to false. Else, if this is also in the up state, but we hit to the top, that is a row equals 0. Then we go right for one step, that is column plus plus, and I have up with false. And else if up, still up, what we will do, that is in the middle of the red line, it is just going to right top. So we'll have the row minus minus and column plus plus. And for this part, we don't need to switch the state. And else if this is in a blue state, that is not up, and if we already hit the bottom, I said row equals in minus 1. Then we go move into the right, that is column plus plus, and we'll say after this move, we'll switch to the red state, that up true. Else if in a blue state and column equals 0, that is hit the left edge, then we'll have the 0 plus plus and up equals true. And else is that the average blue state. What we are going to do is to move to the left bottom, so row plus plus and column minus minus. And this is one more move, and we'll have the index plus plus and return result. So I divided the traverse into 2 states. Only when it hit to the, for example, the up state, it hit to the right edge or to the up edge. It was after one step, it was changed to the blue state. The same thing for the blue state. If it reached to the bottom or to the left edge, they will go right or go down for one step, then switch the state. So it's pretty much like a state machine. For this question, as we traversed the whole matrix, so it will for every cell, so the time complexity will be O m multiplied by n, and the space complexity will also be O m multiplied by n.